Alright, you guys, section 7.2. Quick reminder, when you were multiplying and the bases are the same, you add your exponents. So that would be x to the fifth. When you have an exponent on an exponent, you multiply your exponents. Okay? So here, you're multiplying, the bases are the same, so you add your exponents. So that's x to the 2/3 plus 5/3 becomes x. You have a common denominator, so you just take care of business on top. 7 thirds. I do not recommend that you guys write mixed fractions for exponents. The reason being is that you can see the power and you can see the root. If I wrote that as x to the 2 1/3, is it technically wrong? I guess I would say no, but you can't see the power and you can't, well, you can see the root because it would be a cube root, but you can't see the power. So I would advise you not to write your exponents mixed, that you write them as improper fractions if they are indeed improper. Okay? Here, exponent on an exponent, just like this, you multiply your exponents. X to the 2/3 times 5/3. And in case you guys have forgotten how to multiply fractions, you just go straight across. So that would be 2 times 5 is 10 over 3 times 3 is 9. So that would be x to the 10th, and that would be a 9th root. This would be the same thing. You don't have to rewrite this. I'm just illustrating the point, driving it home. That would be x to the 10th. Okay? Why these are jumping like that, I'm not so sure. X to the 10th. Yeah, it's closing. X to the 10th. Okay? Cube root of 9. Or cube root of that. Okay, there we go. All right. When you're multiplying again, you don't mess with the base. Just like if you had 3 squared times 3 cubed, that would be 3. You're multiplying, so you add your exponents 3 to the 5th. It's not 9 to the 5th. You don't combine the bases. Okay? So you're going to add your exponents. So it would be 3 to the 1/4 plus 1/3. Now you need a common denominator to add those together. To help you guys with this, because right now that isn't something that we're necessarily practicing right now, getting common denominators, you can do it on your calculator. You can type in 1/4 plus 1/3. It'll give you a decimal, and then you hit math, enter, enter, and it will give you x, or sorry, not x, 3 to the 7/12. It will do that adding for you. Okay, but so you type in 1/4 plus 1/3, enter, you get a decimal, math, enter, enter. Okay, here, same thing. Oh, wait, same thing, you can't. I need to rewrite this so it has the same base. That's 3 to the 1/4 times 3 squared raised to the 1/3. This is the same thing. Now I have an exponent on an exponent, so I have to multiply those. 3 to the 1/4 times 3, multiply your exponents. 2 times 1/3. If you need to put the 1 under it to help you see it, and you multiply straight across, that would be 3 to the 2/3. Pick up your calculator, type it in. Let's see, we got 1/4 plus 1/3. 1 divided by 4 plus 2 divided by 3. I get a decimal, math, enter, enter, and you get 11/12. So that would be 3. Oh, already got the 3. Yikes. 3, sorry about that, to the 11/12. Okay? When you were dividing x to the, say, the 5th over x squared, remember when you're dividing, you subtract your exponents, and you do the subtraction where there's more of them. Here, that I hope you can see, 5/3 is bigger than 2/3, so you do the subtraction where there's more of them. 5/3 minus 2/3. When you're subtracting, you just take care of business on top when you got the denominators are the same. So that would be 1 over x to the 3/3. which I'm hoping you guys quickly recognize that's 1, so it's 1 over x to the first, or just 1 over x. Okay? Here, the numerator has the bigger exponent, so you take care of business upstairs. 5/3 minus 2/3. As we saw in the last problem, that's going to be 3/3, or x. If you want x to the first, that's fine, or just x. Okay? Here, you could distribute that exponent in right away, but because the bases are the same, I'm going to go ahead and do the inside first. So that's 3. You're multiplying. Bases are the same, so you add your exponents. 1/4 plus a half. I'm hoping you guys can do that without your calculator. 1/4, think of 25 cents, plus a half, 50 cents, is 75 cents. So that's 3/4. A half plus a quarter is 3/4. So that would be 3/4, and you're raising that to the 5th power. So when you have an exponent on an exponent, you multiply your exponents. And when you multiply fractions, you're just going to go straight across. So to make that look like a 2, I apologize. So that's 3 raised to the 15/4. Okay? When the size of the root is the same, you can bring them together underneath the same root. So that would be 5 times 7, or the square root of 35. When the size of the root is different, that's where I think it becomes very helpful if you guys think of this as fractional exponents. Okay? 5 to the half times 7 to the third. Okay, because the size of the roots are different, there's nothing really you can do. There is an advanced, I guess I could say, technique. If you got common denominators, then you could bring these things together. This isn't something you're going to be practicing that much, but I need to illustrate what I'm talking about. If the size of the root is the same, you can bring these together, just like I did here. Okay? If they were both the same size root, so in effect, I need to get a common denominator. The common denominator is 6. So I'm going to multiply this by 3/3. Sorry, that's kind of crunched. So I get 5 to the 3/6 times 7, and this one would be multiplied by 2/2. Oops, 7 to the 2/6. That's the same thing as the 6th root of 5 cubed times the 6th root of 7 squared. Now they have the same root. So I could bring it together as the 6th root of 5 cubed times 7 squared. And that would be your answer. I don't really think there's a reason that you have to multiply that. It would be a giant number. So I think it's fine just leaving it the way it is. This is a square root. So that would be 5 to the half times 5 to the third. I have to have common denominators in order to bring them under the same root. So the common root again is going to be 6, just like it was in this one. So I'm going to get a common denominator by multiplying this one by 3/3. So I get 5 to the 3/6 times 5 to the, and this one gets 2/2. That's times, not minus, 2/3, 6. Because the bases are the same and the root is the same, I can bring these things together into the same root. So this would be the same thing as 5 cubed, 6th root, well, 5 cubed times 5 squared, which would be the 6th root of 5 to the 5th. Okay? Now, I could do this because the bases are the same, is just thinking of it this way. 5 to the half times 5 to the third. Because the bases are the same, you can add your exponents. And when you add these on your calculator, you're going to get 5/6. 5 to the 5/6. And you add that on your calculator. A half plus a third is 5/6. And that means exactly the same thing as it does here. Okay, so I hope those two methods are confusing for you. Feel free to ask questions on them. This one poses a little bit of a challenge because all the rest of these, their exponents were 1. Okay, here their exponents aren't 1. 8, I'm hoping you recognize as 2 cubed. So I'm going to rewrite this as 2 cubed, and it's inside a square root. And that's a cube root of 2 cubed. Yes, that could pop out, but hold on a second. We're going to bring these together. That's going to be 2, they're square roots. Okay. Oh, that's a cube root. That's 2 to the 3 halves times 2 to the 3 thirds. When you're multiplying, you add your exponents. So it's going to be 2, and if I go 3 divided by 2 plus 3 divided by 3, I get 2.5. And if you do that as an improper fraction, that's going to be 5 halves. So that's going to be 2 to the 5 halves. I would be happy if you guys left your answer like that. If you wanted to write it as something with a root, it's a square root, and it's 2 to the 5th. Okay, not much for 5. How about that? 2 to the 5th. This one, 4 is 2 squared. So we got a cube root times a cube root of 2 to the 1st. The roots are the same size, so you could bring these things together. So you could go a cube root of 2 cubed. And you're gonna, okay, if that bothers you, let me back up a second. Here, I jumped ahead, I skipped some steps, so that might bother you. Okay, so you can bring it together under one big root. 2 squared times 2 to the 1st. That will give you the cube root of 2 cubed, which I'm hoping you recognize. When the power matches the root, they cancel out, and so your answer is just 2. Okay? You could avoid the whole thing of rewriting it if you wanted in this particular case, because they're both the same size root, like up here. They're both square roots, so I brought them together and multiplied them together. This, they're both cube roots, so I could bring it together, and you have 4, cube root, 4 times 2, so I have the cube root of 8, and if you can recognize the cube root of 8 without rewriting it as the cube root of 2 cubed, you go, oh, the answer is 2. So depending on your comfort level with roots. These are both 4th roots, so you can bring it together like I just did here. 4th root of 7 squared. Now, here's where it becomes a little more interesting. This root is larger than the power, so nothing's going to come out. But if I think of this as a fractional exponent, that would be 7 squared raised to the 1/4 power. So you have an exponent on an exponent, you multiply your exponents. So that becomes 7 to the half. So this reduces to just the square root of 7. Okay? Yeah, you got to go there. Okay? Here, they're different size roots again. So I'm going to think of it as 5 to the 3rd times 5 to the 1/4. I'm simplifying the inside before I deal with this. All right? You have the same base, so you add your exponents. 1/3 plus 1/4. Grab your calculator. Sorry, that turned out looking like a 9. 1/3 plus 1/4, and you get math. Enter, and you get 7/12. So that becomes, whoa, what is that? 5 to the 7/12. Now don't forget that still there's this exponent of 12 out here, to the 12th power. When you have an exponent and an exponent, you multiply your exponents. You have 5 to the 7/12 times 12. And I'm hoping that you remember that you can cancel when you're multiplying fractions, and you get 5 to the 7th power. I would recommend you leave it there. If you type that in your calculator, you're going to get a big honking number. All right? You could have, if you wanted to, at this stage here, sorry to always be giving you options, you could distribute the exponent in right now. And so that would be 5 to the 1/3 times 12 times 5 to the 1/4 times 12. Sorry, I closed the 4 again. 1/3 of 12 is 4. So that's 5 to the 4th. 1/4 of 12 is 1/3, or not 1/3, is 3. Whew. 1/3 of 12 is 4. 1/4 of 12, because this cancels out, and you get 3, is 5 cubed. So once again, you get the same answer as doing it the other way. All right? Okay, here. When you have the same size root, you can cancel stuff out. Like here, they're both square roots. I can reduce this first. So that, oops, I already got the, okay, never mind what I was trying to do. 8 goes into itself once, into 32 4 times. Square root of 1 is 1. So this becomes then the square root of 4. And you guys know what the square root of 4 is, so that would be 1/2. Here, I can't do that. But what you can do is you think of it as 5 to the 1/2 over 5 to the 3rd. You're dividing, so you subtract your exponents. And I hope you realize that 1/2 is bigger than 1/3, so you're going to do the subtraction upstairs. 5 to the 1/2 minus 1/3. And again, you pick up your calculator and you go math, enter, enter. Well, okay, you got to type it in first. 1/2 divided by 1/3, and you get a decimal, math, enter, enter, and you get 1/6. So you get 5 to the 1/6 power. Now, I think you're welcome to leave it there. It also means this, just reinforcing what the two things mean. I would accept either one of these as answers. Okay, we did that one. This one, similar to this, they're the same size root, so you can reduce. 4 goes into itself 1, into 32 8 times. The cube root of 1 is 1, and you're left with the cube root of 8 on the bottom. And hopefully after looking at cube root of 8 earlier, the cube root of 8 is 2. So that would be your answer. And nothing's farther down. Coming over here. All right. You got to prime factor these things. This is stuff that I did last semester, so the kids I had are familiar with this. So break it out into prime numbers. 2 goes into 24 12 times. Stick with 2. 2 goes in there 6 times. 2 goes in there 3 times. So 24 is 2 cubed times 3 to the 1st. So when you have the square root of 24, that's 2 cubed 3 to the 1st. 2 goes into 3 once, so the 2 is, a single 2 is going to pop out. 2 goes into 3 once with the remainder of 1, so you have a 2 left behind, and this 3, the exponent's not big enough, so it's got to stay. 2 square roots of 6. Go into this one, that's 2 cubed times 3 to the 1st. The powers match, so it pops out. This one's not big enough, so it's got to stay behind. Don't forget the cube root symbol. And then looking at the 4th root down here, you got the 4th root of 2 cubed 3 to the 1st. None of the exponents are big enough, so nothing happens. It stays the 4th root of 24. It's as good as it gets. Okay? 80, got to prime factor it. 2 and 40. Hey, I didn't get a 9. 2 and 20. 2 and 10. 2 and 5. So that becomes 2 to the 4th times 5 to the 1st. So the square root of 80, square root, if I had to help you see it, is 2 to the 4th times 5 to the 1st. 2 goes into 4 twice. This is the 2, twice, with no remainder. So there's nothing of 2's left inside. And the 5 doesn't have a big enough exponent, so it can't come out. The cube root of 2 to the 4th times 5 to the 1st. 3 goes into 4 once with 1. I don't know why I wrote a 3. I apologize, you guys. That's just screwing you up. Let me erase that and say it again. I apologize. 3 goes into 4 once with 1 left over. 3 goes into 4 once with 1 left over. 3 can't go into the 1, so it stays put. So that would be 2 cube roots of 10. Come down here to the 4th root. It's a 4th root of 2 to the 4th times 5 to the 1st. 4 goes into 4 once with nothing left over. And the exponent of the 5 isn't large enough for anything to come out, so it stays put. All right, 162. Not as bad as it looks. 2 and 81. 2 doesn't go in anymore, so we go to 3. 3 and 27. 3 and 9. 3 and 3. So 162 is 2 times 3 to the 4th. Okay? So you got the square root of 2 times 3 to the 4th. 2 goes into 4 twice. There's the 2. 2 goes into 4 twice with no remainder. And the exponent on the 2 isn't big enough for anything to come out, so it stays at. You're welcome to leave it as 3 squared, or you could write 9 squared roots of 2. And remember, with the square root, the 2 is optional. The cube root of 162 is 2 times 3 to the 4th. The 2 doesn't have a big enough exponent, so for sure, it's got to stay behind. 3 goes into 4 once with 1 left over. So 3 cube roots of 6. And going down to the 4th root, so that's the 4th root of 2 times 3 to the 4th. Once again, the 2 doesn't have a big enough exponent, so it's got to stay put. 4 goes into 4 once with nothing left over. Do I need to put the 1 as an exponent? No. I'm just doing it to illustrate the point. So that would be your final answer. Okay, when you got variables, no big deal. 16, when you prime factor it, 2, 4, 2, 2. So that becomes the 4th root of 2 to the 4th, x to the 4th. The power matches the root on both of them, so everybody pops out once. 4 goes into 4 once, 4 goes into 4 once, so your answer is just 2x. 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2, 1, 2, 3, 4, 5. So it's the 4th root of 2 to the 5th, x to the 5th. So 4 goes into 5 once. 4 goes into 5 once, so I get a 2 that pops out with 1 left over. 4 goes into 5 once with 1 left over. So it's 2x, a 5th root of 2x. Okay? When you're multiplying, and if they're the same size root, you can bring the stuff together. 3 square roots of y to the 4th. You added your exponents because you're multiplying. Over square root of 9y to the 8th. You guys are welcome to reduce first. They're both square roots, so you're welcome to cancel stuff out. Bam, that cancels that out. That reduces to a 4. Okay, that's pretty darn messy. I don't even know if I can read that. Okay, and that reduces to a 4. So what I'm left with is 3. There's nothing left in the root, so there's nothing up there. The bottom is 9y to the 4th. 3 is upstairs. Square root of 9 is 3. The square root of y to the 4th, 2 goes into 4 twice. And then the 3's reduce, and you have 1 over y squared. Okay? They're both cube roots. I can bring everything together into one big root. So that's 4x y to the 5th times 6x squared. You're multiplying. 4 times 6 is 24. X to the 1st times x squared is x cubed. Y to the 5th. Okay? And it's a cube root. 24, remember, is 2 and 12, 2 and 6, 2 and 3. So that's 2 cubed times 3 to the 1st. So rewriting that, I've got a cube root of 2 cubed times 3 bringing this in, x cubed y to the 5th, and now you start pulling stuff out. So I got a cube root. 3 goes into 3 once, so a single 2 pops out. This 3 doesn't have a big enough exponent, so that 3's got to stay behind. 3 goes into 3 once, so the x pops out. 3 goes into 5 once, with 2 left over. So trying to rewrite that a little cleaner, 2x y cube root of 3y squared. Okay, and that's all underneath it. Oh my gosh, finally. So last screen, so there you go.